Everybody, it's Tyler here at Championships, checking in 63-28 mechanical advantage. What a phenomenal team this has. Of course, hopefully you've seen all the phenomenal things they do through Open Alliance as well too, and keeping their robots open and accessible for you to see what's going on. But we're gonna take a deeper dive here today on Behind the Bumpers. So much to go into this. You know, when I think mechanical advantage, I think of their phenomenal different types of ways that they're handling software, but they have a phenomenal side as well too mechanical. This is just an absolutely gorgeous robot they'll be going through too. Lots of different spots we're going through, of course, following that full note journey as well, and we jump into the software. So let's learn more about them coming up here on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
Matthew, let's start out talking kind of ground up from here. Walk me through your intake area, and then we're going to be going as well with Advate, talking about the different mechanical features of this robot.
Yep, so starting off here on the back, we have a full width under the bumper intake. So if you notice on the bottom here, we have two leading rollers, and then those have little wedges that initially center it almost into the center here. And then from there, it snakes up a little bit more. Well, we have passive centering rollers with slippery tape on them. So that gets it centered leading into the arm. And from there, it goes in, hits the kicker roller here, and then that leads into the indexer, which Advate will talk a little bit about.
Yeah, so our indexer here, you'll notice something cool about it is it has double-sided HDD belt here. And so this eliminates the need to use gears to switch direction on these rollers, and it makes packaging really nice because we need these two rollers to be spinning in the same direction, but at the opposite direction of this. This indexer allows us to shuffle the note between our two note paths because we want, we have one note path for our shooter and one for our amp and trap score. So we need to be able to switch between them whenever we want. So we'll do a little demo of the intake and index shuffle feature.
So I really like in that shuffling, by the way, that you're queuing here essentially, and then you can choose right away after. Some teams to talk to, they almost have to like go all the way up into the shooter and then bring it back through, and even that little bit of time can make a big difference.
Yeah.
So I love the thought process gone into that.
Yeah, exactly. And speaking of shooters, our shooter over here, so we control each half of our shooter independently, so not the top and bottom, but the side and side, each side. So we have the motors all the way back here too at the end of our arm to keep our CG lower and the inertia of the arm lower because we need to be swinging it up and down. So we have the orange stealth wheels here. And yeah, so we spin them each at different speeds, and once one half spins faster than the other to put rotational inertia on the note and keeps it on a stable flight while we shoot. So Matthew can talk about the amp backpack.
Yeah, so the other direction in which the note can go is the amp backpack. So the amp backpack scores in both the amp and then eventually in the end game the trap. So what it is it's basically a sliding carriage in which the note will come down, go up, which I can demo here. This all happens while we're amping, while the arm raises, and then from there, it goes up and it snakes back down. Once we're inside the amp, it'll go down the slot, which we can do a quick demo of here. And then we can score here.
For those who didn't watch on OA Show, why did you end up calling it the backpack on your robot?
It's just kind of on the top of the arm, so it kind of stores on the back, so it's kind of just a backpack for the arm.
Cool. Let's go into your climb sequence and how you're doing your trap as well.
Yep. Yeah, so if you look here, this is our climber. It's a one-stage elevator, and on the carriage, we have our two hooks here. It's just one motor and one gearbox powering two sides, powering the climb, and there's two sets of 25 chain driving it. Yeah, so it's just a single stage and it comes up. And so another thing we want to talk about for the climb sequence is what we call the fangs on the side here. What they do is because when we climb, we go from the outside of the stage down under the chain. We need to be able to route the chain up and over our shooter and our amp backpack because there's some gaps in here that the chain can get caught into. So these fangs allow the chain to get routed over so we have a nice smooth climb. So intake. And then we're gonna put our arm up to get ready to climb. The hooks come up. And then we would drive under the stage, under the chain. It would come down, fall under here, and fall into the gaps of these, when we put the arm up, it would drop down here, fall under the gaps of these hooks. And then we'd move the arm forward a little bit and then drop the hooks down. And then this amp backpack would extend with this rack and pinion system. And then this allows us to score on the trap.
I really like that pulsing as well too. I've seen a couple other really high-end teams do that.
Yeah.
It just seems like you just get a little bit more accuracy on that every single time you go through.
Another interesting thing about our trap score is sometimes if we're a little unlucky and the note kind of doesn't fall right into the trap and it kind of stays outside, that pulsing, the pulsing of these rollers allows the note to kind of stay within this system and get routed back into the trap even if it misses the first
Last time I
time.
just want to ask you from a mechanical side of things, your team has gone through so many iterations this year, creating from like building essentially an alphabot all the way through. Anything you want to mention in regards to kind of that journey or process?
Yeah, exactly. We actually wanted to talk a little bit about our development bot, or alphabot. So we started off with that one, and we slapped a lot of our prototypes on that bot. So like when we were first developing our shooter prototype, we went through a lot of iterations as like just a shooter. And then once we found like a pretty good subsystem, we just like took that prototype as it was and put it onto like this superstructure that we designed. And same thing with like the amp backpack. We went through like 15 or something iterations about on how to route the note. And after we found like a pretty good prototype, we literally just slapped that right onto the DevBot. So that allowed us to have some drive practice, develop some autos on an initial robot earlier in the build season while we were developing the real version. But it also showed us some of the mistakes we might have made, where we can assemble better, and how we can make slight improvements in our real design and our competition design. So our development bot was really helpful in that sense.
Start talking about as we work into the software side of things. Anything you want to mention in regards to the cameras on the bot?
Yeah, so we have 4 cameras. We have 2 on these swerve modules, 1 in the middle here, which is a zoom lens, and 1 on the intake over there. And the mounts for these cameras are all SLS printed TPU. And so I'll hand this over to the software team to talk about our vision system.
Sorry, talk to me more about how you're implementing that from a software end.
All right, let's put the arm back up. Yeah, so just like last year, we have 4 cameras placed around the robot, and they're all looking for the April tags. So we have 2 on each corner, 1 in the back and 1 here. And what's really nice is that we put a lot more strategy into the placement of the cameras. So this camera is mainly looking at the speaker tags as we enter the wing. And this is actually a different lens than the 70-degree lens on the OB2311. So this is a 60-degree lens, and this is actually a 90-degree lens on the inside there. And this actually, we can weigh this 40% more than the other 2 standard lenses. And we found that this can actually give us, this is like our most useful camera as during our autos, and especially during tele-op when we're trying to get those far shots in. Yeah, so the main pipeline is running on these 2 orange pies here. So 2 cameras per orange pie. And this is actually cut down from last year where we had 4 cameras on 4 individual orange pies. And the main reason for doing this is just like the electrical kind of having powering and actually setting up 4 orange pies is really difficult, and cutting it down to 2 has actually improved our layout here, right? So also the pipeline is pretty much the same from last year, which we've been developing since the 2022 preseason. And the main reason we want to have such a robust localization system is during auto, whenever we encounter another robot.
Yeah, so this is just a simulation of one of our auto routines pulled from a log file from one of our matches, as well as the actual video. So you can see here, the green lines show when we're detecting a tag, and the yellow poses show like the individual tag poses and just how we're following this path. So you can see we're actually following our path quite pretty well, and even when we contact another robot here, we don't deviate from our path. We get right back on it and actually complete our auto routine. An interesting thing about our auto path here is that if you see these yellow lines, these represent the trajectory that we generate. And something new this year that we're doing is actually using numerical optimization as opposed to spline generation to generate these trajectories. We run our numerical optimization trajectory generator on a Docker container that we then communicate over gRPC. This has been really interesting, so you can talk a little bit more about, but basically we're able to really accurately define our trajectories to create the most optimal path between 2 waypoints. So sir, you want to talk a little bit more about how we actually follow that?
Right. So what's also really neat about the solver is that it will tell us the actual force each module will output relative to the field. And then we can convert that to a set point torque in its local heading of the module and actually use that as a part of our feed forward. So we can accurately match the set point acceleration as well as velocity, which is really new for this year and also helped us in our following. Right. So talking a bit more about our autonomous selection. So just like last year, we can select like a high level auto routine, which one, the first one we call spiky auto because it scores the spike notes. And we give it a few questions which we can answer. So for example, the starting location and how many spike notes. This is actually a new development for this competition, the Thinking on Your Feet auto. So actually here, there's a list of all of our auto routines. You can see the general idea behind the Thinking on Your Feet auto is that you do a sweep of the center line until you get a note, and then you come to the nearest scoring location and just shoot from there. So that's helped us. I think in the last match, we kind of skipped 1 and 2 notes from the center line just because another team had took them already, and that has proved to be really helpful coming in.
Well, last thing I just want to ask you guys, we're seeing more and more teams using AdvantageScope out there as well too. For a team that might be interested in getting involved with AdvantageScope, what advice would you have to get them first started?
So yeah, AdvantageScope, this is new this year. AdvantageScope is actually included in the 2024 WP Alpha installer. So you already have it on your laptop. And we've also posted lots of documentation online about how you can get started with just logging in general and using AdvantageScope to visualize data. So there's lots of resources available online. I just encourage all of you to at least take a look, try out logging. It can help you in many ways. And yeah.
Awesome. Mechanical Advantage, thank you for being such an inspiration to the first community. Everything you've done has just been great. From Open Alliance to the AdvantageScope things, there's so much that you just providing resources. Phenomenal robot as well too, so we wish you best of luck here at the World Championships and can't wait to see how you do. Thanks a lot for telling us more about it.
Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.